Hello everyone, my name is Rimvydas, and I worked on a project in collaboration with Translated that was about spoken language identification from audio files. So the problem of spoken language identification is you are given an audio file and you need to say what language is being spoken in it. And they are short utterances, 3 to 10 seconds. This can be used not only in multiple language online translation, which Translated does, but also in other applications such as call center routing or data labeling. So the approach that Translated currently took was to basically send multiple parallel requests to a speech recognition service. So they would send the audio file as different languages and then use the obtained confidence score to say what language it was. However, there are a couple of problems. First of all, it is really slow because you have to wait for the longest response to come back. And in practice, it can take up to 5 or even more seconds. Also, as you add more languages, this becomes really expensive because, for example, if you have 100 languages, you need to send 100 requests for a single audio file, and each request costs money. It also gets less accurate with each language added, and for more than 2 or 3 languages, it can get as low as 70%, and it gets slower. And this means it doesn't really scale well because adding a new language negatively affects all of these aspects. So my approach was, first of all, to convert the audio files into an image representation, specifically to spectrograms, and then use state-of-the-art image classification techniques to predict the language from the spectrogram image. And the model that I trained is basically an improvement over all of the aforementioned aspects. Namely, it is much faster. You only need one call for saying what language it is, independent from the number of languages you're choosing from. And it is also much more accurate. And it is really easy and straightforward to add more languages. You just need 5 or 10 hours of spoken data. So for future work, first of all, we found that the data that you're using to train your model is really critical here. And you have to be very careful about controlling certain aspects of what audio files you're using to train the model. We can also use data augmentation to obtain more samples from the limited set of samples you already have. And I'm confident that the production release of this service, we can reach accuracy that is higher than 90%, at least for 6 languages, and we can reduce the prediction time even more to be sub-second. And I'm confident that we can produce a solution that for, let's say, when you have 100 languages, that is at least 60 times cheaper than the solution that Translated currently use. So thank you for your attention. I want to also thank Translated for sponsoring the project and my mentor, Lukas Kaiser from Google Brain.